Okay, here we go. I will do my best. Number 7. I don't want to do number 7. I'm just kidding. All right, let's see. Number 7. So give the third degree Taylor polynomial. So I really hate natural log. Like, it just bugs me. The way it looks bothers me. I feel like it's difficult. I almost feel like, so this would be easiest for me to construct this myself as opposed to worrying at all about substituting in, especially because I'm not centered at 0. I'm centered at 2. So I'm going to go ahead and I'm going to do this the long way. So f of x is natural log of 3 minus x. I know I don't have to write that out, but I did. I'm going to find my derivatives, and then I'm going to go through and plug in 2 for each one. I have to get to a third degree. So I have to get down to a third derivative to plug this in. So my first derivative is 1 over 3 minus x times negative 1. Don't forget, when I take the derivative of natural log, I put 3 minus x on the bottom, and derivative of it on the top. That's actually probably a better way, rather than worrying about a multiplied negative 1. So that's fine. All right, I want to take another derivative. I don't want to use quotient rule if I can avoid it. So I'm going to rewrite this as negative 1 times 3 minus x to the negative first. So now my second derivative will be 1 times 3 minus x to the negative second times negative 1. My third derivative will be, this negative 1's really out front, so I'm going to have now 2 times 3 minus x to the negative third times negative 1. So that's 3 derivatives. That's all I'll need to get a third degree polynomial. So now let's plug x equals 0 or x equals 2 into each one. So we're going to evaluate each of these at x equals 2 to write the Taylor polynomial. When I plug x equals 2 into this, I get the natural log of 1, which is 0. When I plug 2 into this, I'm going to get 3 minus 2 is 1 to the negative 1 times, so I'm going to get negative 1. Plug 2 into this, I'm going to get negative 1. Plug 2 into this, I'm going to get negative 2. Okay, so let's use all of those values for my function and its derivatives to write the Taylor series. So my Taylor series will be, whoops, let me give myself more space. So f of 0 plus the first derivative of f. Oh, I'm sorry, not f of 0, f of 2. Sorry, f of 2 plus the first derivative at 2 times x minus 2 plus the second derivative at 2 times x minus 2 squared over 2 factorial plus the third derivative at 2 times x minus 2 to the third over 3 factorial. So let's see how this reduces. So we're going to start out with negative. So I know I'm either choice A or B. My next term is negative 1/2. So it's got to be this. And let's just double check that this reduces, because this is 3 times 2 times 1. This reduces to 1/3. So yep, we are choice B. All right, number 8. Number 8, I wanted to go over in class because it's different than anything else. So this will be the first time you've seen a problem like this. What is the polynomial approximation for the value of sine of 1 obtained by using the 5th degree Taylor polynomial about x equals 0 for sine x? Okay, they're asking you to find the series for sine x all the way up to the 5th degree. So all the way up till the highest power is 5. So you can grab your little pink sheet if you want, or remember, okay, x is the odd, so we're going to start with x. Then we have minus x to the third over 3 factorial plus x to the 5th over 5 factorial. That is a 5th degree Taylor polynomial. There it is. They want me to approximate the value of sine of 1. So they want me to use this to find out what's the value of the sine of 1. All I got to do, I'm going to use that approximation, is plug 1 in for this polynomial. So 1 minus 1 over 3 factorial, which is 6, plus 1 over 5 factorial. 5 factorial. I'm just grabbing a calculator because it's easier from my head. 5 times 4 times 6, 120. I knew that. Oh, nice. I don't even have to reduce. There we go. Letter E. Beautiful. Okay, number 9. What is the coefficient of x squared in the Taylor series for this about x equals 0? So notice this is not a geometric series that I can substitute into, because this bottom is really 1 over 1 plus 2x plus x squared. This is not a geometric series. Cannot use geometric series for this. I'm going to have to construct it from scratch. I only have to go to the x squared term, so I only need the second derivative. So this is the first, that's the function. I'm going to rewrite f as 1 plus x to the negative second, because the derivatives are easier to take when it's written like that. So the first derivative is negative 2 times 1 plus x to the negative third. And the second derivative is 6 times 1 plus x to the negative fourth. That's all I need. So I don't need to go construct the entire thing. I think when I first started doing this, I did construct the whole thing. I plugged x equals 0 into each part, and I constructed the whole Taylor polynomial. I really don't have to. It's not like it's wrong if you do, but I can skip right to the power of 2 term, because that's all I need. So I would usually go, f of 0 plus f prime of 0x plus f double prime of 0x squared over 2 factorial, but I can skip right to here. So my second degree term is going, I need to plug 0 in for this. I haven't done that yet. So when I do, I'm going to get 6. So this term is going to be 6x squared over 2 factorial, which is going to reduce to 3x squared. So what is the coefficient of the x squared term? It's 3. Okay, 10. Which of the following is the Taylor series for f about x equals 0? This is a tough one. So x times sine of 2x. First, let's remember what sine of x is. We already did it 2 problems prior. So sine of x I might want more terms. I'm not sure. I'm going to stop there and see if I need to go further just to really get a good picture. Now I'm going to figure out what is the sine of 2x. What's the series for sine of 2x? So I'm going to substitute. Take out the x, put in 2x. Take out the x, put in 2x. Take out the x, put in 2x. Okay. Now let's also multiply everything by x. So that gets distributed and multiplied by every term. So this is going to become 2x squared minus, all right, let's do some reducing here. So this is going to be 8x to the fourth, oops, that's a 4, over 3 factorial, so over 6. This is going to become 32x to the 6th over 5 factorial, which is 120. So let's see what my match is. I know that my first term is 2x squared, so it's either D or E. This is 8/6. Oh, whoops, they kept the factorials. Oh, sorry about that. This would stay 3 factorial. This can stay 5 factorial. So 8x to the 4th over 3 factorial. That's what I'm looking for. 32x to the 6th. Good. So the answer is E. Okay, number 11. A function has this series. Which of the following is an expression for f of x? They love questions like this, and they're not easy because it's almost like you have to try out all 5 answers to see which one might be this. We can hopefully do some canceling out of things that don't make a whole lot of sense, but I don't know. I did not do these ahead of time, so you're gonna have to bear with me while I work through it. I'm gonna try to do some process of elimination maybe instead of what would work, and maybe you guys would be better. I don't know, I'm thinking C might be likely. because I know that cosine is the even powers. If I'm putting this on, but I have all pluses. It's the only thing that's freaking me out a little bit. All pluses is usually more an e to the x thing because sine and cosine both alternate. So that's one of the things I'm thinking. Sine and cosine alternate. Now, who knows what happens with all this plugging in? Maybe the alternating would fix itself. I have no idea. This could take a while because I'm going to do some trial and error. I'm going to try D first. I'm just going to try it because it has an e to the x and it takes out my first couple of terms. And it also, look, e to the x doesn't skip over powers. It's not evens or odds. It's all of them. So this kind of pumps up my e to the x and then takes out the first couple of terms. So I think we might have it. Sorry if I sleuth it out and get it right the first time. It would be okay if you guessed and checked for a little while. But let's see. So let me start by just figuring out what this series would be. So e to the x is all of my terms, all addition, all positive, no evens or odds, is just everything. So there's e to the x. Okay, so what's x squared e to the x? Well, that's going to be, this isn't substitution, this is multiplying. So I'm multiplying everything by x squared. So this is x squared, this is x to the third, this is x to the fourth over 2 factorial, this is x to the fifth over 3 factorial. And now I'm going to subtract out. I don't really feel like writing all this out, but I'm going to take this. I'm going to subtract x to the third and subtract x squared from both sides. It's going to cancel that term and that term. And I'm going to be left with this, boom, which is the answer. It is only experience that allows me to work through that at a pace that's somewhat quick and just trying to reason. I mean, I could have been wrong, but I tried to reason like, oh, I have all the powers here, not just evens or odds, and I have everything addition. That really leads me to an e to the x type situation. So if you went through and you guessed and tested and tried to try the other ones, it shouldn't have worked out until you got to there. I apologize. That's a gnarly problem. Okay, this is a lot like the one we did in class. Here's a polynomial. What is the value of the third derivative of 0? So remember, the Taylor polynomial centered around 0. For that third degree term would give me the third derivative at 0 times x to the third over 3 factorial. That should match this. Hope everybody's okay with that. This term, which would yield an x to the third, needs to look like, or needs to match this term once it's reduced. So how do you figure out what the third derivative is? Well, the third derivative of f at 0 divided by 3 factorial should be the same as negative 5. So the third derivative at 0 should be negative 30. A. Last one. Oh, yay, this one is so nice and easy. Hopefully you feel like this is a confidence boost at the end. So they're giving us all these values for 3. What's the Taylor polynomial at x equals 3? So we're going to have f of 3 plus the first derivative at 3 times x minus 3 to the first plus the second derivative times x minus 3 squared over 2 factorial plus the third derivative times x minus 3 to the third over 3 factorial, and so on and so on. And so this will reduce. They're trying to trick you here. If you pick those, it's because you forgot about centering it at 3. Those terms still are good. We should reduce this, so don't get tricked into this one. Yeah, it's got the 6, but it didn't divide by the 2. So this is going to reduce and become 3. So it's one of these. And this is going to reduce. Remember, it's not 12 over 3. They're trying to trick you with that. This is 3 factorial. This is actually 6. So this reduces to 2. So the answer is A. All right, hopefully you're feeling a little more confident. You should feel confident with 13 and 12. 11's pretty tricky. 10's borderline, but decent. And then 9, although it's a long journey, you know where I got all that stuff. And 8 is new to you, but I hope it makes sense once you watch the work. Yay. Goodbye.